Okay, we are doing chapter 15 of Heinman. Question 1. Select the correct statement about amino acids. Amino acids contain only the elements C, H, O, and N. That's incorrect. If you find cysteine here, cysteine has a sulfur in it, so that's incorrect. All 20 amino acids needed by humans are known to be essential amino acids. That's also incorrect. Only 9 of them are essential. That is, humans can create the other 11 within the body, and only 9 have to be consumed directly. Amino acids may contain more than one nitrogen atom. They can. See, this is tryptophan, and there's 2 nitrogen atoms. It's crazy. The functional group on an amino acid side chain is always nonpolar. That's also incorrect. There are polar side chains. Yeah, that's incorrect. Let's find one. Glutamic acid. That's a polar functional group. So the answer is C. Question 2. What 2 functional groups are present in all amino acids? That would be the carboxyl group and the amine group. The amino group. 3. Draw the general structure of an amino acid. Okay. When they ask you to draw the structure, it's better if you don't leave out any of the bonds, even if they're mostly implied. So writing O and then the bond and then H instead of just OH. That's the side chain. That is not the side chain. That is the side chain. Another one. Color the amino group in blue and the carboxyl group in red. The amino group in blue and the carboxyl group in red. Nice fat marker. Okay, there we go. Aspartic acid is one of the non-essential amino acids shown in figure 5.8.1. It exists mainly as a Zwitter ion at pH 2.8. Name the acidic functional group COOH. Name the basic functional group NH2. What is meant by the term Zwitter ion? 2-ion. A Zwitter ion is a compound, a molecule that has the same amount of positive and negatively charged groups. So you have one positively charged group and you have one negatively charged group. It's equal. Okay. Draw the structure of the molecule that is likely to exist in a solution at a pH greater than 2.8. A pH greater than 2.8 is more basic, meaning lots of OHs to take away the H. So since it's already basic, the NH2 stays as it is. And because it's basic, the acidic parts, oh, that is a lovely COO. The acidic parts will do the deionizing. At a pH much less than 2.8, so that's a more acidic solution than what it would be a Zwitter ion in. Acids means the base with much lower pH means lots of H plus around. So the NH2 is going to take another H. Circle there. And since there's already lots of H's in solution, the carboxyls will just stay as they are. And finally, at 2.8, which is where it's a Zwitter ion, would be, that's the one ion, that's the other ion, 2 ions, 1, 2. Okay, what's next? When alanine and glycerine react, 2 different dipeptides are formed. Write the condensed structural formula of each dipeptide. Much better. That's alanine, and then what was the other one? Glycine. I'm a big fan of glycine. That's one. And the other is the other way, with the glycine coming first. And then the alanine here. What's next? How many tripeptides can be formed with 3 amino acids? Well, if you have 3 amino acids and you're forming a tripeptide, you've got 3 spots. You've got 3 options for the first. Wait. Are duplicates allowed? We'll assume no. And since you've used up 1 already, you've got 2 options for the second. You've got 1 option for the last one. That's 3 times 2 times 1, that's 6. Circle the peptide links in the section of a protein chain shown in the figure. This boy, and this boy, and this boy, and this boy. Okay. Write the formulas of the amino acids that make up this section of the chain. Like, renaming them. Okay, CH3, that's alanine. CH2SH, there's not a lot with sulfur. It's cysteine, that's glycine, my favorite. And then serine. So A, they are needed as an energy source, is true. But in that case, you could consume any fatty acid. It doesn't have to be omega-3 and omega-6. B, they're the best form of energy storage. I'm pretty sure they are not energy storage. But there's other things that are also energy storage. Like, what's it called? Glycogen. But they cannot be made in the body from other organic compounds, so you have to consume it for those omega-3 and omega-6. D, there are oils rather than solid fats. Well, it's definitely not the best reason, given C is there. It's not really a consideration. Describe bonding between carbon atoms in the hydrocarbon tails in the following types of fatty acids. I guess the more unsaturated it is, the worse it is at packing, and so the bonding is just gets worse and worse. So it's saturated because there's no double bonds. All of the C to C bonds, they can swivel freely. And so they can pack very close to each other, and there's strong dispersion forces. When you have monounsaturated, you've got one double bond, which is rigid, and so the fats don't pack together as well, and the dispersion forces are weaker. When you get polyunsaturated, it gets even worse, as in the dispersion forces get even weaker. The structure of the fatty acid linoleic acid is that, okay. Name the chemical required to react with linoleic acid in order to form a triglyceride. It's glycerol. Ta-da, glycerol. Draw the structure of the triglyceride made from linoleic acid. C. The H is in. There's an O. We connect it to the carboxyl group, and then you kind of get the idea. We just copy this backwards each of these times. I'll find the linoleic acid. C17 H31 C17 H31. Okay. Name and circle the functional groups. The functional groups are ether groups. They're the carbon and the two oxygens here. Classify the triglyceride as saturated, monounsaturated, polyunsaturated. We see two double bonds, so it's polyunsaturated. There's multiple double bonds. Is this likely to be solid or liquid at room temperature? I'm gonna go with solid. I lied. I'm gonna go with liquid. The more double bonds there are, the weaker the dispersion forces are. And if the dispersion forces are weaker, then it's more liquid. So protein's function depends on its shape. And when you change one of the amino acids, you might get a different functional group, a different R group. So then it interacts with the nearby amino acid differently. For example, if you get rid of a cysteine and replace it with a glycine, you don't have that sulfur, so if you needed a disulfide bridge, that no longer happens. And this will change its tertiary structure. Well, it has the potential to change the tertiary structure. And so if the shape doesn't shape correctly, then the protein doesn't work. Why do you need fatty acids? How are polyunsaturated oils such as sunflower oil converted to a solid form? They are saturated. Yeah, you take the double bond. So you got a double bond here. We'll just yeah, it goes on that way. It goes on that way. And so you break that double bond and you put two hydrogens onto it, and that saturates it. It's an addition reaction. What's the difference between omega-3 and omega-6? The omega-3 is on the omega third carbon, and the omega-6 is on the omega-6th carbon. So if you have a fatty acid, C. Okay, that's enough. Then you get different color. This here is the omega carbon. On the side, this is the alpha carbon. So you go 1, 2, 3. And if the double bond is here, that's omega-3. 1, 2, 3, 4, 5, 6. If the double bond is here, it's omega-6.